Hello, my name is Maiwa. In this session, I want to talk about MCP, Model Context Protocol. I'll look at it from a very practical perspective by designing a restaurant recommendation AI agent that's built on top of MCP. This is going to be first of my many videos on AI related stuffs. So if you'd like to get notified, please push the subscribe button. MCP is simply a standard way for AI agents or AI applications to connect to external tools and gather external data. Think of it as the standard way for agents to gather more context or the way for the agent to execute functions. So what are the components involved in MCP? The first one I want to mention is the MCP host. MCP host is basically AI application. Think of it as your Cloud Code. Think of it as your Cloud desktop, your Chat GPT, every AI applications that you've used. That's your MCP host. Now, within an MCP host, you have what we call the MCP client. That's basically a library that helps in facilitating MCP transactions. Now, let's look at the transport layer as one of the components involved. This is basically the layer that handles the transfer and passing of messages between the MCP host and the MCP server. There are two core things on this transport layer, which is the transport protocol and the messaging format. HTTP plus server-side event is what MCP uses as transport protocol, and JSON RPC 2.0 is what it uses for the message passing. And on the other side is the MCP protocol server itself. The MCP server is the one that exposes the tools, the resources, and prompt template to the MCP host. We're going to go into more details around what exactly do you get from tools, what do you get from resources, and when do you even need it? Why do you need some of them? That's why we'll be designing a practical use case with a restaurant recommendation agent. Now let's talk about tools. Tools are functions. However, you don't just expose the function the way we expose them as APIs. You have to wrap them in a way for AI agent to consume and to discover. So that's basically about tools. They are stuffs that AI agent can execute. Uh, Usually, a tool would have side effects. It could be writing the database. It could be doing every computation. It could even be invoking some reasoning as well. But that's the basics for now. On the resource side of things, resources, think of it as data that provide context to AI agents. Or this can be files, this can be API response. They tend not to change, although they can change over time, but they are not as flaky as whatever response a tool may provide, because tools will mutate, resources don't mutate, they just read data. And then the final one is the prompt template. Think of prompt template as a bunch of instruction on how to execute. This is largely used for workflow based action or task. Now, on the MCP side of things, it also provides some things. We just looked at what the MCP server provides. Now, let's look at what the MCP host also provide as well. There's a concept called sampling. Sampling is the ability for the MCP server to invoke reasoning um, by using the LLM on the MCP host. This way, we give the MCP server the ability to reason along with the tools and resources that it has. The way for the MCP server to be able to use the LLM capability is via sampling. Root is also one of the things that the MCP hosts provide. This is just providing knowledge of what the user file system and workspace looks like. Think of it as context for MCP server. That's just what root is all about. What's the file system? What's the file permissions? Or what directory are you currently working on? All of these basic file level details or directory level details is what roots provide. Elicitation is the way for the server to invoke the user to provide either an approval or a decline for a critical decision. This way, the server can always guarantee that whatever the agent is trying to do, there is a user approval behind it. So this is how user data is protected against illegal access by AI agents. We'll look at use cases where elicitation is coming from the server and it's also coming from directly by the agent. And the final one is notification. Notification is just letting the MCP server know when there is system changes or file updates, file permission has changed, there's an external trigger, so that the MCP server can respond to those changes effectively. So this is the way for MCP hosts to notify the MCP server of changes. Now that we understand all the details about MCP hosts, the transport layer, and also the MCP server, let's talk about let's look at the practical use case of how we will design an AI agent to find top rated restaurant nearby. Bear in mind that during this design, my focus is I want to use or leverage a lot of MCP component as much as possible. So this is not necessarily saying this is the best way to design this kind of agent. Or if I was supposed to be designing it for a production use case, I would consider some more things um, like business use case and also engineering trade-off. But for this training purpose, let's look at some of the MCP requirements that we need before we go ahead and design our agent. Since it's a restaurant recommendation agent and it's meant to recommend restaurants that are nearby, it's definitely going to need the user location. And the MCP capability that we'll be touching there is the elicitation. And also, we would need to maybe know about the user history, their review history, the restaurant they visited, uh, and all sort of things like that. So we need a way to fetch user data. We're going to assume that Yelp API is what we're using here. So we'll call the Yelp API to fetch user data. So this way we expose what we call a tool for that. And we also need a tool to like effectively search for restaurants. This is definitely going to take like maybe the current lat long of the user. And a couple of things are going to happen around there. We'll look into like this because this is not just doing a search. This is doing a search of based on the user's preference. And there needs to be a way for you to know what the user preferences is or what the user preferences are. And this is where based on the user preference or requirement, we need to introduce something what we call like preference signals. Here we'll be leveraging the sampling that the host provides to MCP server. With sampling, basically what we want to do is review the user's profile, which is review history, dining history, and use LLM to give us signals about the user. And once we have restaurant recommendation, we'll just tell the user to like select and confirm. We're not going to go into the details of how to like make a reservations and do some booking. So, but that's an exercise that you may like to take care of. Now let's start with what the sequence of activity looks like between the agent which is the agent that is going to reside on the MCP host and the MCP server as well. Let's look at what the sequence of the activity is going to look like. The first thing is between the MCP host and the server, there's a step called initialization, which is basically exchanging of capabilities. So they're saying the MCP host is going to declare to the MCP server, look, I can give you this capabilities, which is sampling. I can give you capabilities around elicitation. I can give you capabilities around notification. All the things that the host can do, it declares it. The same thing happens on the server side as well. Everything that it can do, like providing tools, the tools it can provide, the prompt it has, and also the apologies, also the resources that it can provide as well. So uh, the server declares it. So what's happening here is just basically declaration between the MCP host and the server. Now, once that is done, think of it like, oh, you have your Claude code open or Claude desktop open now, and you're on your prompt interface, and you as a user, you just type in there, find me some highly rated restaurants nearby based on my historical preferences. Now that's the prompt to to the AI agent. Now we have hard coded this to like say it's going to be using Yelp API service and all of that. So let's say it picks up an AI agent that's going to use that service. Now the AI agent picks it up, and the first thing it notices is that it needs to know the user location. And because it needs to know the user location, it then sends an elicitation request directly to the user. Can I use your location? So the user have to like approve or decline at this point. Now, this is what I actually call like the agent initiated elicitation, where it's the agent that is initiating the request. The request. It's not necessarily the server. At this point, but we'll see next as well that we can also have like the server initiated elicitation as well, which is the agent from the host sends a request to the server, maybe kind of declaring their intent to access the user's data. Now you want to access the user's Yelp data, um, and that's what the agent wants to access. But the server is not just going to like provide that data directly to the to the to the agent. It needs to tell the agent to like trigger an elicitation request to the user. And that's what happens here in step 4, which is that the server triggers an elicitation request um, through the host to the user. So that way, it's the user that is explicitly granting or declining the request, or you can access my Yelp data. And until it's able to access the Yelp data, then it might not be able to proceed with the user prompt. Now that the agent has the user's data, that's the assumption at this point, has access to the user's data. Now it can actually like trigger a search request, like, oh, invoke the MCP server tool for searching for restaurant. It maybe will provide it with the lat long of the user and all of that. But the question is, what does the MCP server do from what does it do from this point? Because there are a couple of things that it needs to put into perspective. It's not just searching for restaurant, it's searching for top restaurant, and it's also searching for restaurant based on user preferences. So there is a sub step involved here, which is that it needs to like invoke the LLM to analyze um the user preferences. So what's happening is that the MCP server is going to trigger a sampling request back to the host. This is just the LLM needing to gather the holistic information about the user and then extracting signal data from that and then passing it back, which will eventually be passed back to the MCP server. But the thing is, the LLM eventually would discover that it needs to fetch the user profile, their dining history, their review history, because maybe the MCP server would have indicated from the template prompts provided to the LLM that use this as context for the signal that you're trying to extract. And it identifies that, and in return, it invokes the resource from the MCP server to like fetch the user's dining history, review history, and all of these things. It just invokes it there. And once it invokes it, it gets the data back. And at this point, the LLM can make inferences and generate signals about the user. And these signals can then be passed back the to the MCP server. Now, maybe the signal would have already been structured in a way that the MCP server can pass to its search request. That's my expectation with the prompt templates passed in step one. And now the signal can now be used by the MCP server to do a much more tailored search for top restaurants. Overall, that's how that looks like. We look at we basically looked at how it uses the LLM to kind of like generate user signal, and then the LLM also calls resources, and then it passes back to the MCP server, and then the MCP server can use the signal to like get a tailored or restaurant response. This is one way to design it. There are other couple of ways you could design it. It's usually dependent on engineering trade-off. I'm not trying to like evaluate engineering trade-off here. I'm just trying to use as much MCP component as possible. At the end of the day, the AI agent will be able to like display the results to the user and present it to the user. But what you could try and challenge yourself with is design an MCP for reservation. Like the user select it. You need to think about like the tools to call for reservation. You need to think about like booking status. How would you communicate booking status? You need to maybe think about how would you communicate reservation canceling, including payment as well? How would you collect payment? How would you ensure that the payment is secure and the agent is not just collecting or reading user data without approval? All of those details you need to put into consideration. And I think it's a very, very good exercise to kind of help yourself get into the details of what MCP is all about and get more hands-on. Feel free to put in the comment section, what your design would look like for this. I'm really, really curious about it. And at a glance, what we can really summarize about this is that tools are meant for executing actions, operations. Resources provide context. That's basically what it is. To AI agents or the MCPOs, whatever you want to think about it. And then you also have prompts that serves as like template for workflows. Prompts are meant to serve as guidelines or workflows and meant to serve as directions for LLMs. Um, and you also have like samplings for inferences purpose. It's meant to help the MCP server also generate inferences. It gives it like the reasoning capability as well. So it's we now have a server that goes beyond like logic invocation to function invocation, but now have like reasoning capability included in it. That's huge. That's powerful capability that you have in MCP. And root, of course, gives bonds the context. It tells you about like the file system and the directory. And elicitation is basically gathering user input either as an approver or a direct input. And finally, maybe one of the questions that might have popped up in your mind as you're following this tutorial is, I could do this with skills. Yes, this is much simpler and can be achieved with much easily achieved with skills. There are use cases for when to choose or requirement for when to choose MCP. Those requirements is what I just want to like talk about here. If you want your tools to be exposed to all agents, irrespective of what they are built with or how they are built, and just work with any or all kind of agent, then you'll need MCP. Because skills, then you have to tie it to a specific agent. Another thing that you have to think about is the third party tool as well. So if you're building tools for maybe if you would like to expose your APIs as tools for third-party application, then you need to build tools, or you would like third-party applications rather to use your APIs, then you need to expose them as tools to this AI agent. So uh, that's also one of the reasons why you might need MCP. If it's your agent and it's your API service, then you maybe don't need MCP. You can just wire it up with skills. That's fine. Uh, but if you need a third-party AI application to talk to your API service, then you need to put a tool layer over it or an MCP wrapper over it and expose it for to the third-party application. Uh, Talking about like the language agnostic part of it, you don't have to tie it to whatever your agent requires. Maybe some agent requires Python. And if you maybe need like your agent, your MCP to be really, really performant, then you want to avoid being tied down by language. And that's one of the things, the benefit that MCP also provide for you as well. Like it gives you that language agnostic capability where you can write it any language and interface with any agent. And finally, is the coupling and independent scaling. You don't have your agent and your tooling tied together. You can scale your MCP tool as much as you want, irrespective of the current state of the agent. So that decoupling capability, it gives you a lot of power. And there's so much that we can do definitely with MCP, although it comes with a lot of like overhead of building the transport layer, building the wrapper around the transport layer, doing the connection, doing the tool registry, doing the routing for your doing the routing for your messages, to invoke the right functions and all of that. So there's a lot of like boilerplate setup definitely involved with MCP that comes with a lot of overhead, over skills, but from a scalability perspective and from a universal access perspective, MCP is still the industry standard for this kind of design. And I think that should be all for me. See you some other time. Bye.